Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, computer science professor at El Camino College, Torrance, California. So this is my other control structure video number 1, chapter 9 of my ebook. Today in this video, I'll talk about for loop, and I'll talk about in description of some other loops. But as far as my class is concerned, I will guide you to study rest of the chapter. I may not have video on everything. So let's start this one. So details of other control structures are given in chapter 9 of my ebook. This chapter is the main source of study for this topic. Please rely heavily on chapter 9 to learn about these topics: for loop, do while loops, switch, continue and break statements, enumerations, ternary structures, type definitions, and scope rules. I will not have video on every topic now, but maybe later. Okay, so this is the review of control structures. C++ control structures. We have sequential structures. We did that in lab 1 and 2. In selection structures, we covered basically if and else. We did lab 3 and 4 on that. Switch is in chapter 9. We'll have you read that. Ternary is in chapter 9. We'll have you read that. Repetition structures are very important. In that we did the while loop, that's chapter 7. And we had almost 8 or 9 video on that. So you'll remember that. Do while is on chapter 9. For loop is in chapter 9. This video would mostly be dedicated to for loop. Okay, for loop. When iteration through list, such as array, is needed, or certain algorithm needs to be executed fixed number of times, for loop is very convenient. In for loop, and you'll see that in a second, the loop condition initialization, test of the loop condition, and loop update all are done on the same line and with semicolon separated program statements. Because everything on one line, and because of such spatial arrangement of loop control variables, the loop update, main cause of infinite loops, forgetting to do the loop update is main cause of infinite loop, is rarely forgotten. We show one structure of the for loop now. So please look at this slide for a second. So there's word for, there's left parenthesis, right parenthesis. This part is divided into three parts. Initialization. So remember in while loop there was one step was loop condition was initialized. Test expression, there was the loop Boolean condition testing, and then loop update. And all three are separated by 2 semicolons. Understand this is not a comma. Common mistake made is to forget and put a comma here. Comma is not used as a program terminating statement. This is one program statement, another, and program statements have to be separated by semicolon. So this is not a comma, it's semicolon. Now here it says 0 or more statements. Obviously using 0 statements isn't very effective unless you want to just delay the program by a certain number of loops. So ordinarily you will have something here. So the way it works is that this is done only the first time. Loop counter is set to certain value only the first time. Then it's tested. If test is true, you execute loop statements. Then you do the loop update. This is never done after the first time. You do test expression, true, do this, update, test expression, do this, update, until update is such that this becomes false. So let's see. We'll take a very simple program. We are printing something like 1 potato, 2 potato, 3 potato. So let's look at this loop. Int num. Generally these days int is done here because we don't want it to make visible globally. But this was the old structure. You could do that, but it's better think that this is done here. Okay. So we'll see this structure, this code. When something executes, that will be in the amber band, and we'll just walk through this. And I will ask you questions and pause, and obviously if you're in front of me, you'll answer them. Here you answer them synchronously away from me, and then I'll tell you the answer. So part 1 is initialization. Here num is set to 1. Part 2 is the pretest. For loop is always a pretest loop, just like while loop. We'll test that. Obviously if num was 3, 3 less than 3 is false, so loop will not even be entered. That's the condition of the pretest loop. It may not enter even once, but in this case it will, because num was set to 1. 1 less than 3 is true. So when num was 1, it will print 1 potato. Then num plus plus, it will become 2, and so on. So now we're going to walk through it. So remember 3 parts of the loop. First semicolon separated part is initialization. Second part is loop test or pretest, update, and then fourth is the loop task. Okay. So now we see something called DeMorgan Rule, which tells us what the exit condition would be, or termination condition. So in chapter 6, we talked about DeMorgan Rule. If loop condition is like this, num less than or equal to 3, then loop condition will be, termination condition will be negation of that. Or if we put like this, so it won't apply to this, but it will apply to that. Conjugate of that less than or equal is greater than. So conjugate of that is greater than. So when num becomes 3, that's when loop terminates. So loop pretest condition is opposite of negation of loop test condition. Alright. This is loop. Amber band shows where our code is executing. This is the memory location num, so we'll be looking at that. This is our console where output is being made, and that's the loop here. Okay. I could have print curly brace here, but if you have only one statement, you should be okay. Of course, my instruction will be never to have for loop without left curly brace and right curly brace. Okay. So right now num is undefined. This sets to num to 1. That's the initialization. Now we do the loop test. Num is 1. 1 less than or equals to what is true or false. So now you play along with me as I ask you a question. Is this condition true or false? I'll pause just a little bit and you answer this. So is this condition true or false? Condition is true. 1 less than or equal to 3 is true. So code doesn't jump here, it will jump to this. 1, num was 1, and print 1 potato. So what will print? 1 potato. Then code will jump to increment. Update, so num becomes 2. Then loop condition will be tested again. 2 less than or equal to 3. Is it true or false? Answer this. Answer this. True. So if loop condition is true, I'm going to enter the loop body again. This will execute. Num is 2. So what is printed now? Play along with me. Answer. What will print? Plug in 2 here. Plug in 2 potato. Will be 2 potatoes. Okay. I'll do the update again. Update makes num to 3. And I'll do the loop test again. This is 3. What is 3 less than or equal to 3? True or false? Play along, answer the question. It's true. So I'll enter the loop body again. So num is 3, it will print 3 potato. What is the output? 3 potato. And then I'll do the update again. Update makes num 4. And then after that I have to do the loop test. 4 less than or equal to 3 is what? Answer it. It's false. When it's false, I'll exit the loop. That means this will no longer execute. Okay. When loop control condition is evaluated and has a value false, the loop is set to be satisfied and control passes to the statement following the 4 statements. In this case, we have nothing following the 4. So our output will be 1 potato, 2 potato, 3 potato. If you didn't understand this sequence, please rewind the video again and watch it again until you understand exactly mechanics of the for loop, how for loop works. Okay. Other for loop structures. For loops have other structures. In this one, it ran from low counts to high count, as shown in previous example. But they can also run from higher count to lower count as well. And in previous example, we saw that loop incremented only by 1, integer 1. But there's no such restriction on that. You can jump the loop counter by any integral value, 2, 3, 4. And that's going to depend, of course, the software application. Example of running loop backwards from higher count to lower count is this one. I define count. Count is set to 4. And then it's tested against 0. This time I do count minus minus. So I'm going minus from 4 down to until I've reached 0. And there's a statement done after that. Notice that here we have used the curly braces. It's very important that you use curly braces even if you have one statement. The reason for that I'll have to explain to you another time. So in this loop, count is 4. 4 greater than 0 is true. I'll output the count, which will be 4. Then I'll jump to update. That'll become count to be 3. 3 greater than 0 is true. I'll jump to the printing 3. Count minus minus will make it 2. 2 greater than 0 is true. I'll print 2. It will become 1. 1 greater than 0 is true. Prints 1. Then count becomes 0. 0 greater than 0 is false. False means I'll exit the loop and I'll print done. So that's the example of for loop running backwards. This will, when you see array, or you can see example of printing a string backwards, you can use a loop like this one. People say come up with all kind of algorithm of inverting a string. No need, just print it from back to front using a loop like this one. Loop can use character also as loop counter, and we're going to show example of that in our Xcode compiler. So here I have an example where I'm running loop from uppercase A, and the reason you can do that because every character has a ASCII value, and we just want to print all alphabets, upper and lower cases in ascending order. So first the upper cases and then the lower cases. So we set loop variable char ch equal to uppercase A, and notice the last alphabet character in ASCII table is the lowercase z, so we'll go all the way up to ch less than or equal to z, and ch plus plus. That's because uppercase A has ASCII value 65, B has 66, and all the lowercase are higher than that. So since we want to print only alphabet, they're in between other characters. I do a test called isAlpha. Function isAlpha returns true when ch is indeed an alphabet. Otherwise it returns false. So that will skip printing non-alphabets that are there in between uppercase letters and lowercase letters. Okay. So obviously I'll just walk through a couple of them. ch is A has ASCII value of 65, which is lower than ASCII value of z. So this loop condition is true. I'll enter the loop. isAlpha will return true, will print A. Then I do ch plus plus, that will become B. ASCII value of 66. ASCII value of 66 is less than ASCII value of lowercase z. Loop condition is true again. B is alphabet, so this will return true, and then I print B here. So we'll print A, B, C, D, E, F, all the uppercase letters, and then it's going to print A, B, C, D, E, F, G, H, all the lowercase, and I'll show you the demo here. And that's exactly the case. A, B, C, D, E, F, G, H, I, J, K, L, all the way up to uppercase Z, and then we print lowercase A, B, C, D, E, F, ending with the Z. So it's very important you analyze this code and understand it. For my class, this code will be available. Others, you can kind of pause the video here and take a screenshot and type the code yourself and run it. Now, as I said, loops, count control loops can be run lower to higher value, higher to lower value. We can also print alphabets in the reverse order. For that, I'm just going to comment this code here, but comment in this code which does the reverse. So here we do exactly opposite. I start with lowercase z. As long as ch is greater than or equal to uppercase A, I keep printing, but each time I reduce ch by 1. So if I run this, it'll print alphabets in the reverse order, first the lowercase, then the uppercase. And exactly that's what happened. Z, Y, X, W, ending with A, and then uppercase Z, Y, X, W, ending with A. So look at this code also. Pause the video here, take a screenshot, type it, and run it. All right. So Those are some of the details in for loop. Real application of for loop we'll learn in chapter 10, where we start to use it with arrays. That's probably the most powerful application of for loop. In data structure class, you will learn to use linked list, and there will be use of while loop or for loop at that time as well. Okay, so that's the end of this for loop video. Thanks for watching, and I'll probably have another video in this series where I'll just talk a little bit about do while loop and comparison of do while and while loop, and statements such as continue and break, and then there'll be document that'll give you guidance to read the rest of the chapter 9. Thank you so much.